Assalamu alaikum wa rahmatullahi wa barakatuh. So today we are going to start on chapter 3 of Form 4, which is telecommunication. As the term shows itself, telecommunication has got two main terms making it. We have got tele and we have got communication. So tele means there is an involvement of a distance between the sender of the information and the receiver of the information. And communication involves the sending and receiving information. So that is, if you join them together, telecommunication, you are going to have this involves sending and receiving information over a distance. Sending, which means you have something and you want to give it to another person. Like now I'm talking to you. You watching this video, I'm sending the information in form a lecture to you, and then you are receiving, you are getting it. So that process of sending and receiving is what we refer to as communication. And when you talk about telecommunication, it has to be over a distance from one place to another place. The information that we send are of different forms, and that brings us to forms of information. Number one form of information is spoken information. Spoken information is given through a word of mouth. Like I've told you, now I'm talking. I give speech. A speech is an example of a spoken information given through a word of mouth. That means you are giving a speech. That is a spoken form of information. Number two is written information. Written information, you need to take a pen or you take a computer and then you code a message and then you send to another person. Sending a WhatsApp message, a normal message through your phone, or writing a letter, application letter for a job or application letter for a school learning opportunity is an example of written information. Music. We have got musicians, they compose words, teach us about culture, teach us about religion, teach us about way of life. So by singing about something, you are sending information to your audience. So music is another form of information. We move to diagrams. Sometimes we can draw diagrams to show us directions or to show us the flow of information from a particular point to another. Like today we have got a pandemic of coronavirus. Coronavirus moves from one person to another person. So you can have a person probably somewhere here. This one can be Ahmed, for example. Then this Ahmed touches a table. Here is Ahmed, table, right? And then we have got here Yahi, for example. So if Ahmed touches a table here and he has got coronavirus, he's going to disseminate or transfer the virus from his hand to the table. And then Yahi comes from the other side, touches the table and also gets the virus. So you realize that virus moves from a point to another, and we can represent that using diagrams of people and objects that can be touched to disseminate that particular information. So a diagram is another form of information. Computer data. Every time, like students, when you come to class, you have to follow a timetable. That timetable was generated from a computer data. Someone seated somewhere, maybe your students' affairs, to generate that particular timetable to show that from this particular time to this particular time, you have got physics as a lesson, mathematics as a lesson, or history as a lesson, something like that. The calendar is generated from a computer. So in that particular case, a computer can be used to generate data that can be sent to an audience who receives that. All these forms of information, all of them, can be represented in two broad ways. Representation, how to show. To represent is to show, to give out. So representing information, there are two broad ways. You have got the digital method of representing information, and you have got the analog method of representing information. Here is the difference. We start with the digital. And we are saying digital method of representing information uses what we call binary code system. Binary code, a computer language that understands numbers only. The numbers here are 0 and 1. The numbers here are 0 and 1. At 0, 0 represents the lowest limit of the information, or when the system is off. There is no electrical pulse being decimated from one particular point to another. So 0 represents low information, or the system is off. And 1 represents high end of the information, which means the system is on. Take, for example, the lighting system. You have got bulbs even in this particular hall. You have got a switch. A switch, something that looks like this. And the switch has got 1 and 0 on it. So by the time you press on 1, electrical pulse comes from the source of information or source of power up to the bulb, the filament of the bulb, which then glows. So 1 means there is flow of information. The system is on. When it is high or 1, the system is on, and therefore electrical pulse moves from the source to the device that you are running with that particular electrical information. 0, if you press on 0, the electrical flow is going to be cut off, which means there is not going to be flow of information from the source of power to the device that you are running. And therefore, if it is a bulb, for example, the bulb will not light. You will be in darkness in that case. So that system that uses binary code, the 1 and 0, on and off to represent information, is referred to as a digital method of representing information. And we are saying that the information is in the form of electrical pulses. When you learned about waves, you know a pulse is a wave, which is a disturbance in a medium. It carries energy and information from one point to another point. The example that I've given you with the lighting system, if you press on 1 on, then the disturbance comes from the source of power to the filament of the bulb, which then glows white so that you see the bulb lighting in that case. And if you press on 0, the disturbance cuts off, and therefore there is no light in that particular room or place at that point. So pulse is just a wave, a disturbance in a medium that carries energy and information from one point of the medium to another point of the same medium. The information is discrete. Discrete here means it is definite. It is not continuous. Discrete, not continuous. Not continuous. That is why you have got either the bulb is on or it is off. There is nothing in between. You are either switching on or switching off. That is what you mean by being discrete. It is not continuous. You only have two ends, definite ends. Therefore, it's represented or it is shown using square waves in a diagram. These are the square waves. You know from your mathematics or whatever the science you learn, a square is a figure with both length and width being equal. If you look at these particular things, you have got this here and here. You can complete it to form a square if you want. The other one is here, you can form a square. At this particular point, it means there is flow of information within the medium, and the information is rising in energy or in frequency with time. And therefore, from here to here, it is on. The system is on. The binary system here called on, 1. At this point, it flattens, which means there is no information that is moving from the source to the appliance that you run. So you have got on and off, on and off, on and off. And in this particular case, the energy of the wave is increasing with time. As you come down here, the energy or the frequency of the wave is decreasing with time. So that shows you the discrete nature of a digital information. The next, we are moving to analog information. Okay, in the previous, we talked about digital method of representing information. Number 2 method is analog method of representing information. We said in digital method, we were representing only discrete data, discontinuous data. And that's why we represented using square waves in a graph or a diagram. Here in analog, we are going to represent information that is continuous and discontinuous together. And that is why you have got a continuous sinusoidal wave or a sine wave representing it in a graph. So you come here. This method represents continuous data or information. Data and information are the same. One is raw, one is already processed. And now we are talking about continuous, which means it is an information that is moving from a point to another, and you have to consider it at every level of the path. Take for example, of the example I gave you in digital before. I told you about switching on or off. We would only be interested in whether the bulb is lighting or the bulb is not lighting if it is digital. In analog, we're interested in switching it on and then considering the flow of current from the source through the wire, which is the medium, up to the bulb, to the filament of the bulb, which then glows white for us to see it on or off. So in that particular case, it is a long process. There is an alternating current moving through to ensure that you have got this particular continuous wave. Transmission of sound in air is an example. Like now, right now, I'm talking. The sound comes from my throat through the mouth into the air. It meets air particles, which transfers information or the energy of the sound that I produce from a point to another particle up to where you are, so that you listen to it. So that continuity in dissemination of information is what you refer to as here continuous flow of data or information. And this one is continuous. You realize that the wave comes from here, maybe from the mouth, and then it goes maybe to a point high, and then to another point, and then it reaches your ears. So it continuously moves without a stop. You realize in digital we were having something like this, and then it stops. Then you have another one, and then it stops. In this case, there is no stoppage. The information flows smoothly and continuously without a stop. Basic communication system. Of course, this information that we have said, we have got forms of information and ways of representing information. As you represent the information, it must come from a sender to a receiver. Those components, those parts in a system will compose what is called a communication system. So a system is a collection of different parts, various parts that enable flow of information from the sender to the receiver through various intermediate components. That is what you have here. Cables. Cables can include a wire, like this particular thing, connecting my microphone to the source there. This is a cable. It is capable of transmitting information from me to the camera. So that is a cable. Space can be the atmosphere up here. Someone is talking in Radio Argesa in downtown, and the information flows through air or through space until it is received in the aerial of your phone or of your radio back at home or wherever you are. That is space. So information can either travel in a medium or in a vacuum space. That gives you mechanical and electromagnetic types of waves. And therefore, the wave can be transmitted from one point to another in form of information or energy. These are the components or the basic components of the system. You have got the input transducer. Before I start talking about them, I would like to tell you what a transducer is. A transducer is a device or a machine that converts energy from one form to another form. In this case, we are talking about electrical system. So this input transducer will convert other forms of energy into electrical form of energy. I'm now talking. I produce sound energy. The sound gets into the microphone, and in that particular case, the microphone will act as my input transducer. Inside it, there's going to be vibration that converts that particular sound into waves, electrical waves, to be flown to the destination desired. So this particular point, input transducer, converts other forms of energy into electrical energy for easy flow through the system. Once it is done, there is a process of encoding or modulation. To encode is to change information into a computer language. Convert the sound into a language that is understood by the computer for its transmission in the digital system. Once that is done, the information moves or transmits through the wires or whatever the medium it is up to a transmitter. In the transmitter, there is going to be vibration of waves, interference of waves. That vibration is going to ensure that the source, the carrier wave, is combined or is mixed up with the radio waves inside here. So at this particular point, audio frequency and radio frequency waves are combined together, ready to be disseminated into the atmosphere or into the surrounding to be received at the receiver point at home when you're listening to your radio or watching your television. At the receiver, a receiver can be an earphone, for example, or aerial antenna of your radio. As the waves move, when you tune it to a frequency that is flowing in the air at that particular point, the receiver will detect, the aerial, which is the receiver, will detect that particular frequency and pick it so that your radio or your phone can play to the tune that comes from that particular source frequency. Once it is received in your radio or in your phone or whatever the device you are using to get the information, it is supposed to be decoded or demodulated. You realize that here, audio frequency and radio frequency were combined, mixed together. And radio frequency waves are not safe for your eardrum. So at this particular point, we are supposed to separate the audio frequency and radio frequency waves so that we only have a wave audio frequency safe for your eardrum. So at this particular point, we do the reverse of encoding. We retrieve back the information, the source information, the audio frequency that was added to radio frequency at the transmitter. Once it is safe, it comes at the output transducer, and as I said, a transducer is a device that converts energy from one form to another. This is the reverse of that. So at the output, that is like a speaker, like my mouth, for example. This particular one will convert electrical form of energy into sound energy that can easily get into your ears. Then you receive the information and code it in your brain. That's all about basic communication system. I need to break it down. In the next few minutes or seconds, I'm going to break it down so that I have the basic or the main components of an electrical communication system.